Hi, everyone. I'm Maryam. I'm software engineer at JCSDA and M-Cubed here at UCAR and NCAR. And today I'm going to talk about continuous integration in the JEDI project and also WRF model development with a focus on automated testing framework that we have. So before I start, I want to thank my co-authors and also people in the JEDI core team for their help with this project. Okay, so this is just an outline of my talk. I'm going to give a brief introduction of why we need an automated testing and also the Agile methodology in scientific programming. I will introduce application of some of the modern software engineering tools that we can use in scientific programming, and then I will talk about automated testing framework and the use of containers in that. And then I will give some details about automated testing and continuous integration in the JEDI project. And then at the end, I will briefly talk about the automated testing that we have in the WRF model development currently. So in scientific communities, mostly a traditional method of software development is used. That means that if a scientist or a scientific programmer wants to add a new feature to an existing code, they will set a goal for themselves, and then they will start working on that feature. So that will maybe take months or even years to complete that feature. And then after that, they will request to merge that new feature into the main repository. And then reviewers will review that code, and then after that, they need to ensure that everything is working correctly, and then after that, they will merge that new feature into the main repository. So the problem with this method is that because you're adding a big chunk of code to the main repository at one time, it can make the reviewing process very difficult. And if there's a bug in the code, it will be very difficult to find and fix that bug. And also keeping track of all the changes, it's usually impossible. And that will decrease your code reusability and reproducibility. So the modern software engineering approach suggests to break your code into smaller pieces, basically break your main goal into smaller pieces, and then add the code into the main repository little by little. So this is more like an iterative process that you get to have your code will be reviewed in the smaller pieces, and you get to test that small piece that you're adding to the main repository. So this will make the review a lot easier, the bug fix a lot easier. And also, you can keep track of all the changes that you are making into your code. And if someone wants to reproduce your code, it's going to be easier for them to do that. So this method is called Agile Methodology. And we use a variation of that in the JEDI development currently. So some of the tools that can be useful in order to implement the Agile methodology into your code development process are listed here. So the first and most important one is of course, version control system, or VCS. I'm sure everyone is familiar with that. So these are tools such as Git, GitHub, and GitLab, and I'm not going to talk about them today. So the next is automated testing framework, because testing is such an important part in the Agile methodology, because you need to test your code in each iteration to make sure it's working correctly. So there are tools available for this that we can use. Some free tools such as Travis CI, or some tools that you need to pay for, such as Jenkins or AWS Code Build. Another very useful tool that we can use in Agile methodology, or like in anything, basically in software programming, if you want to have a portable code, are containers. And services for that are Docker, Charlie Cloud, or Singularity. And I'm going to talk about these two last tools in this talk today. Okay, so here I'm showing a schematic of testing workflow. Let's say you have a GitHub for your VCS control system or any version control service that you're using. When a developer wants to add a new feature to the code, they will issue a PR to the code. And then when the PR is in place, the reviewers will take a look at the code. They will run a bunch of tests. So they will build the code and test it to make sure it's running correctly. So because the testing and building and testing process is a manual job, it can be very time consuming for reviewers, and they will not have enough time to actually pay attention to the quality of the code or the scientific aspect of the code that's been added. And then because, as I said, it's a manual process, it's very prone to errors and it's time consuming. So what we did and what's, I mean, it's not a new innovation that we did. We just used the tools that are available for this fact. So what we used in the JEDI project and also in WRF development is that we added this automated testing piece to the process. That means that the testing, building and testing of the new feature will be done through an automated process, and we are using cloud computing heavily for that. So we use AWS Code Build for and Travis CI for JEDI, and Jenkins for WRF for the automated testing process. And then when we have that in place and reviewers are seeing that the build is the new feature is building and all the tests are passing correctly, they can focus on the quality of the code and the scientific aspect of the code that's been added. So if all the tests pass and if the reviewers think that the code is working correctly, we can merge the code. We can merge the new feature in the code. But if there's a problem, the code will go back to the developer, and they are in charge of reviewing the code to make sure everything is working correctly. I mean, fixing that and push it back to the PR. So as I said, containers are a very important aspect in this process. So containers are basically very similar to virtual machines. You can build different dependencies, dependent packages that you have for your code inside the containers. And then when you have everything in place inside the container, you can use that container multiple times on different platforms, such as, for example, automated testing platform, or if you're on an HPC, you can load up the container with all the dependencies packages on your HPC cluster. And also you can easily load that into your workstation and run your code without needing to build and install all the dependencies. So this will, so having that, using containers, different containers with different configurations in automated testing can ensure the portability of your code. For example, in the JEDI automated testing, we have three different containers, each built with different compilers and MPI and other packages, different versions of the packages. And then we use these containers in order to test our code inside each of them to make sure that everything is working correctly when we are adding a new feature. So a bit about the JEDI project. JEDI stands for Joint Effort for Data Assimilation Project. It's a very big project, meaning that we have lots of collaborators and contributors from different agencies, and it's because it's it's developing really fastly. We have a lot of commits and PRs each month to the core JEDI repositories. So the main code is based on C++, and we use CMake to build the code and also C tests to run all the tests that we have in each of our repository. As I said, we mostly use AWS Code Build, and AWS ECR is where we save and store all our Docker containers. So we use the Docker containers here, and then also AWS to run the code. And then for our smaller repositories, we use Travis CI which is free but has fewer resources, computational resources available, and Docker Hub for automated testing for that. So here I'm showing, kind of providing some details about the configuration of AWS Code Build that we have for JEDI repositories. So whenever we have a new pull request or a commit to an existing pull request, we trigger 3 different code build projects. Each of these projects are based on a different containers. So for example, we have one based on Intel compiler, one based on GNU compiler, and one based on CLN compiler. So when we trigger these 3 code build projects, we can run them in parallel. And then so we basically load up the new feature that's added to the that is in the PR and is going to be added to the code. We load that into each of these Docker containers, and then we will build the code with that new feature and also run all the tests based on that. So the output of this code build and then the status of each code build project will be printed on the PR page. For example, we use GitHub, so we can see that we can see the status under the check section on the PR page. If it's a green check, all the build was successful and all the tests passed, we also have a status that's a yellow circle that's still pending, so it means that everything is running. And then the red cross means that something failed in the code. So also there's an option that you can make these passing, successful build and passing of all the tests as a requirement. So if you don't have a passing status for any of these code build project, you are not able to merge the code into the PR. So this kind of ensures that everything is passing before merging the PR into the main repository. So just some more details is that in JEDI, most of our tests are unit tests. So these are very small tests that checks and makes sure that the functions are working correctly in our code. We also have tests that compare the output with a known answer. And the test will pass if the answer that we calculated is equal to a known answer within an acceptable range or tolerance level. So in order to add AWS Code Build to our project, it's not very complicated, and there are lots of resources available that you can use. But you need to basically on AWS side, you need to kind of define the computational resource that you want to use, like how many CPUs or how much memory you need. You need to define the Docker container that you want to use for your build and run. You need to define the triggers that basically trigger code build. For example, for our case, is a new PR or a commit to an existing PR. There's also a YAML file that you need to add to your repository and also set the name on AWS. And then this YAML file includes step-by-step instruction of building the code and running the tests. Sarah, so here I just put part of this YAML file here. So as you see, these are step-by-step like commands that you can pass to code build. And then so this line basically configures the code. This one builds the code, and then you will run ctest in this line. And then if you click on the link that's on the PR page that shows the status, it will take you to the code build page with the output there. So you can see the output for each of these lines that you run in code build. And then, for example, this is for one of our repositories where we have 311 tests in that repository. And then you can see that all the tests pass, and this will result in a green check in the PR page. So if there's a failure in the test, you can see it in the summary page in the output, and then later it will also show some details of why these tests failed in this specific run. So regarding the cost estimates, as I said, there are different compute instances available. So small, medium, large, and there's also ARM and GPU available that you can use for your code build projects. So we usually use medium and large instances for the JEDI project. And the cost really depends on how much development is done in our repository. So it's like one of the important features of cloud computing is that you will only pay for what you're using. So you can clearly see that in this plot, that you can see the weekly cycles in the code development that we have. So no cost during the weekend, and then higher cost if we are adding a new feature and there's a heavy development going on, and then lower cost on days that people are lazy. Yeah, so in general, we have 21 code build project in JEDI. And then so this means that we have it for 7 different repositories and we run 3 different containers. So this is 21. So builds take about 20 to 45 minutes, depending on the code that we are building and depending on the repository that we're testing. And the cost for the JEDI project is about $500 per month on average. But as I said, it can vary greatly from month to month. So another tool that we use in the JEDI project is CodeCov. So this tool will test how much coverage you have, how much test coverage you have in your code. For example, if there's a new feature added to the code, but there's no test with that feature, no test is added with that feature, then the code build check will fail in that PR. So this ensures us that we are always increasing the test coverage, and we are actually testing all parts of the code that we have. So CodeCov will print something like that in the PR page that will show the places that coverage is increased and then show the places that it is decreased. If you go on the CodeCov website for your repository, you can see a coverage numbers plot similar to that, and it's an interactive plot. If you go over each of these circles, it will show you which part of the code is having a good coverage or poor test coverage. So this way you can you can be sure that you're testing all different parts of your code. So this is part of an effort that we are currently working on, and this is one of our main goals in this year for JEDI continuous integration. So JEDI is a very complicated system. So we have multiple different repositories, and then we have code built separately on each of them. So the new plan is we plan to run JEDI application, meaning that we are planning to run a complete data assimilation cycle with the most recent code in the repository that we have every week. And in order to be sure that these weekly runs are running correctly, we need to make sure that the code that we've been added during the day in the repository is working correctly and all different pieces are compatible with each other. So we are going to set up nightly runs using AWS Code Pipeline, Code Build, and also AWS Lambda function to test the whole system and run comprehensive testing and application running of JEDI system. And then we will dedicate a web page to that and then print the result for that on that so developers can review it. Okay, now let's move on to the WRF model development. So the automated testing in the development of WRF model is a collaborative effort between MCube Lab at NCAR and Scala Computing. So the logistic is very similar to what we have on JEDI, meaning that whenever there's a new PR or a commit, the tests will trigger. But Jenkins, along with AWS EC2, are used instead of AWS Code Build. for this testing framework. So Docker containers are used heavily in this testing framework, meaning that we have a Docker container embedded into the EC2 instance, and then whenever the tests are triggered, 48 different instances will get triggered, and each of them will test either different build involved, for example, different dynamical core or different configuration, or run different name list options, and then the results are then gathered from these 48 different containers and compared to each other to make sure that we are within a tolerable difference between these different runs. And again, the test result will be printed on the PR page as an example here, you can see. And also it will be emailed to the developer so they can look at the details if there's a failure there. And then this, they usually run between 60 to 100 tests every month, and that costs between $250 to $350 per month. And again, because it's a cloud computing source, you will just pay for how much you're using the code. So if there are more commits or PRs, it will cost more, but if there are less, it will be less costly. So this has helped greatly with the efficiency of code development, both in WRF model and in the JEDI project. With that, I'm going to stop, and then thanks for your time.